Now, because we started this topic concerning the capacity building, Jota, please, the floor is yours. Jota is going to present ongoing activities supporting the capacity building. Jota, it's your turn. Sorry. But before this, sorry. No, I was wrong. I was wrong. The first, again, the same topic, of course. Expert support for capacity building, Yannis Papaphilippou from CERN. Sorry, excuse me.
Good morning, everyone. Thanks a lot for inviting me in this meeting. I'm Yannis Papaphilippou. I'm leading the Accelerator and Beam Physics group at CERN. And I have also, my heart, if you want, is in Thessaloniki because I'm the visiting professor of the Aristotelian University of Thessaloniki, where I teach actually accelerators. And because the subject is capacity building, I will actually treat it from a bit Greek-centric perspective and through the CERN experience, okay? So a bit of history, what already you heard from my good friend Emmanuel Tsesmelis. Greece is among the 12 founding member states of CERN since almost 70 years now. It has a large, very large particle physics community. Okay, we are talking about, we always say that Greece, the particle physics research is done at CERN. We have more than 200, these are numbers from 2020, of particle physicists. 20 years ago, accelerator science, if you want to accelerate, Greek science for accelerators, apart, if you were going back to the books of, I don't know, about strong focusing, and you would hear a big name, Nicholas Christophilos, there was none, okay? There was none, or there were single people around the world. And what we tried to do is to bring, if you want, some knowledge as knowledge transfer of accelerator physics and technology through PhD students first, technical students, master students, and then PhD students. So we started this activity for the last 20 years, and I will just flash you a non-exhaustive list of PhD students in accelerator physics. They are coming mostly from 3 universities, but Greek, but also they are affiliated, some of them, to other universities. And the subjects are very, very variant. Of course, they are core to CERN. They are for particle physics research. They are core to the, if you want, our business. And of course, the interesting part, and we are talking about brain drain, if there was an infrastructure, an accelerator, if you want, in Greece, probably these people would have come back and helped with the design, operation, etc. of these accelerators. There was none, so they continued, most of them, their career as postdocs at CERN. The interesting part is some of them now are my colleagues, they are staff. We were the number of people, Greeks at CERN, at the accelerators sector, has grown, I would say, by a factor of 10 over the last 20 years. And now I'm talking only about these 5 among the PhDs that you see here, which are higher than CERN. There are many more that they are coming from engineering, etc., etc. So, as I said, we are dealing with our field and the projects that these people were touching, their studies. It is about the CERN injector operation and LHC injector upgrade. Actually, this is very, very close to what a medical accelerator does. We are talking about a source, we are talking about a LINAC, we are talking about ions, H- now, but before it was protons, and we are talking about a low energy synchrotron. And then, of course, because it is our business, it's collider business, we are talking about the LHC, high luminosity LHC, this compact linear collider studies that were done through these PhDs, low emittance rings, helping synchrotron light sources, future circular collider, etc. And just I flash you some highlights of their work. This is a recent PhD, Tisi Prebibai, very interesting. He's Albanian but also Greek. He's from a National Technical University of Athens initially, but now he has his PhD in Frankfurt, and he works on improving the brightness, which is the ratio between number of particles to the emittance of the booster with different techniques, either through optics correction or trying to minimize the tails of the distribution or trying to mitigate what we call space charge effects. Another example, the PhD of Sofia Kostoglu. Sofia again, a person from an electrical engineer from the National Technical University of Athens. She worked on LHC, NHLHC noise studies. One of the biggest problems that we were having, we had a question mark. The beam 1 of the LHC was different from beam 2. We couldn't understand why. Well, the solution came, or at least indications that this is the problem came from the PhD of Sofia, where we find that power converter noise could impact the beam lifetime of mainly one of the two beams. And this we did it with very, very dedicated studies where you see that beam 1, the noise, the spectrum of these power converters was entering into the beam spectrum, and it was perturbing the lifetime by limiting it by an order of, let's say, 5 over the 27 hours of lifetime that we had in the LHC. Very interesting also, PhD of Kostas. Kostas is a University of Thessaloniki student. I'm in his board for the PhD thesis with my colleagues of the particle physics laboratory here in Thessaloniki, and he's talking about electron clouds. Again, LHC, HLHC, electron cloud is a very, very difficult effect. It impacts actually not only, I mean, it can make the beam unstable, but also it can create losses. And there was a theoretical framework and a tracking code, and all the software infrastructure was built through the PhD of Kostas in order to be able actually to simulate this effect over a long time scale and being able to be predictive. So these are some nice plots where you can see the resonances that are impacting the dynamics of the particles at injections in the LHC. And the last, but not least, I flash you highlights of these PhDs that we had. It is Kyriakos. Kyriakos is from the University of Creta. He did his studies in what we call a compensation of the beam-beam effect. Colliders, you know, they cross, the beams cross. This is a very disruptive effect. You are limiting your lifetime, and you can realize that actually by putting some current-bearing DC wire, you can compensate the effect. Actually, this is something that we build a prototype right now, and we are operating in the machine. And the PhD of Kyriakos was targeting, if you want, the improvement that you could have in the luminosity, in the integrated luminosity of HLHC through this technique. So how do you, I mean, we're talking about building capacity. How do you go about, I mean, there is a lot of collaboration agreements with Greek universities. And right now I flash 3 that I'm aware of. And these are collaboration agreements which are basically signed in a very broad, let's say, range of subjects of accelerator physics and technology. And we have, of course, one with the National Technical University of Athens covering a lot of these studies, the University of Creta, and, of course, the Aristotelian University of Thessaloniki. And with this type of collaboration agreements, we can host, actually, students of course, there is always need of some budget associated to a project or covered through CERN if it is part of our core, business, which can support them. Now, what are the areas that we developed? Actually, Greek scientists at CERN, they developed an expertise in all of these areas. And okay, I'm here to, of course, testify the accelerator and beam physics part, which is the design part of the accelerator. But then we are talking about people who are working in accelerator operation right now. Even at the technical level, we have technicians actually who are doing that. Experimental areas, of course, this was already an area that I would say it was quite well developed because it is an area which touches very much particle physics on the secondary beam lines area. Radio frequency systems design, including low-level RF, accelerator controls, beam instrumentation and diagnostics, magnet design, cryogenics, power converters, and accelerator controls. I put it twice because it's very interesting. Sorry. So, and I just flash you two things from the expertise that Greek engineers and physicists they have right now at CERN. This is from my colleague Kostas Papasterigiou, electronic power converters. You know, at CERN we operate a large number of power converters, and what is the critical part of, in particular, these power converters is that we want them extremely precise. You've heard that some of them, even if they are so precise, the noise from the network can penetrate, and we can see it in the beam of the LHC. So you can imagine that there is a very interesting research in order to even go beyond this 1 part per million, which is a very difficult, I would say, area of research to target for the precision of the power converters. And then, as I said before, this is again from my colleague Nikos Haritonidis. He was part of the PhD students actually, and he became staff at CERN. Secondary beam lines, we run a spectrum of secondary beam lines where, for fixed target experiments, where of course we hit a target and then you produce particles, and then depending on the energy, you can of course do irradiation for Atlas or LHCb, or even you see here you have argon ions for Na61, for example. I will end basically my talk by saying that, I mean, in order to build this capacity, you need to educate people, as you said. So you, of course, education can be done at CERN with all this PhD, but I believe that education should be done also locally in universities. And it started actually in Greece with undergraduate courses of accelerators, just to whet the appetite of physicists or engineers, of the audience, you know, of the young students. And again, the three that I know and were in collaborators was mainly NTUA, the School of Applied Mathematics and Physics, the Aristotelian University of Thessaloniki, and the University of Creta. But then we started also in a Master of Science course in accelerators, and I'm teaching this since 2020 at the Aristotelian University of Thessaloniki, where I get from 5 to 10 master students per year, which are mainly from the particle physics, but also applied physics, if you want, domain, and they get a full semester course, the whole 9 yards of accelerators. We were thinking even to have an accelerator laboratory with a colleague on beam instrumentation. Unfortunately, COVID made the situation very difficult, but I can tell you this can be done. So, and of course, the other part of CERN, I used to be actually part of the coordinators of the CERN Accelerator School and of the organizers, and we had a school in Chios, an intermediate one. A lot of students from Greece participated in that school back in 10 years ago. Nice photos in front of the beach or of the sea. And then we had a later one, not a long time ago, in Thessaloniki, an advanced course. And then, of course, we had a lot of other possibilities to send students. There is the joint, there is USPAS, of course. Now USPAS, by the way, you can do it online. United States Particle Accelerator School. Linear collider schools, we sent very targeted to, again, our business for linear colliders. JUAS, actually there was even a CERN accelerator school on medical accelerators back in 2015 in Austria. Why not try to get another one? Covered by, let's say, initiated by this community here, and in particular located in the Balkans. So the summary, it was just to tell you that it is step by step. It does not come from day one, but for the last 2 decades we tried to build a critical mass of Greek accelerator scientists in a large spectrum of expertise in beam physics, design and technology. And basically, I believe that this is a very solid base, if you want, in order to support targeted studies for the design of a hadron cancer therapy center like the one that we are discussing here. And this is all. Thank you.
Thank you very much. So, question, comments? I don't see any. Thank you very much again. Very interesting talk. I have a short question. So, out of all these young people which we succeeded to train, how many of them are really in Greece back?
Well, we were talking about brain drain, and
yes,
I think that I mentioned it. Most of them stayed abroad, and actually not even in the accelerator field, because at a certain point you are so well trained in subjects of engineering or, for example, advanced, we are talking about machine learning, artificial intelligence. We have competitors, in the market right now, in particular if you get trained in this type of fields. So actually none of them, to my knowledge, came back to Greece. Probably we have a couple of them who made some spin-off companies in Greece, in particular on magnet design. This is the only, at least to my knowledge, this is the unique, if you want, example of Greeks who came back to Greece and made a small company, like a spin-off of their studies at CERN. Most of them stayed abroad. And I repeat, they stay abroad because there is no infrastructure to absorb them. And this is the important point for me. This is the key point.
Yes, yeah, thank you. So, any other? I don't see. So, Jota, now it is really your turn.